Hi, good morning, everyone. Let's continue on this Grenfell Fire 2017. Today, we will discuss one of the root causes of the Grenfell Tower fire in 2017, focusing on the regulatory failures of the performance-based fire cook, particularly the use of combustible cladding and the lessons we can learn to prevent such tragedies in the future. Today's discussion focuses on the critical challenge in the construction industry, harmonizing performance-based and prescriptive cooks to ensure safety, compliance, and innovation in building practices. While performance-based cooks provide flexibility for creative and innovative designs, allowing for tailored alternative solutions that meet the unique needs of projects, but sometimes it can be costly to check compliance. Thus, prescriptive-based acceptable solutions are usually provided, which offer straightforward, standardized approaches that are easier to implement and verify. However, the challenge lies in ensuring that these two frameworks work together seamlessly. Acceptable solutions often rely on industry certifications as evidence of compliance. However, certifications may not always guarantee reliability. Factors such as outdated standards or variations in interpretation can lead to inconsistencies. How to harmonize the performance-based requirements and the prescriptive-based acceptable solutions becomes a critical challenge that caused the Grenfell fire in 2017. To address these issues, we must focus on developing robust mechanisms for evaluating industry certifications and fostering collaboration between regulators, industry stakeholders, and building professionals. This will enable us to achieve a balance where performance-based solutions are encouraged while prescriptive cooks maintain their role in safeguarding consistency and reliability. One of the key factors in the Grenfell fire was the use of aluminium composite material ACM panels with a highly flammable polyethylene core, as we mentioned in our previous PowerPoint. Although certified as Class 0, these panels act as the primary fuel for the rapid spread of the fire. This raises a critical question. Why did UK regulations allow the use of such materials? The shift to performance-based fire cooks in 1985 marked a move from prescriptive rules to more flexible compliance methods. However, this flexibility, compounded by deregulation, reduced oversight and opened avenues for cost-cutting, compromising fire safety. Section B4 of approved document B, which provide prescriptive-based acceptable solutions, outlined two compliance routes for external cladding materials, namely, 1. Achieving Class 0 certification, or 2. Meeting limited combustibility requirements. However, these routes were not equivalent, leading many stakeholders to opt for the less stringent Class 0 certification. In 2002, The Guardian explicitly warned that satisfying Class 0 did not equate to limited combustibility. Unfortunately, this warning was removed in the 2006 revision, creating confusion and allowing dangerous materials to be used in high-rise buildings. Here I direct quote paragraph 13.7 from the document on external wall construction, and you will find that indeed it refers to diagram 40 and where it shows about the conflict of the two requirements. Diagram 40 in the approved document B treat Class 0 and Euro Class B as equivalent. However, Class 0 focuses only on surface spread of frame, while Euro Class B measures broader combustibility properties, highlighting a critical regulatory gap. Here I direct quote Rockpanel's explanation on the key differences between Class 0 and Euro B. All too often, Class 0 is being compared to Euro Class B because both are mentioned in existing regulations. However, Class 0 is not and can never be comparable to a Euro Class system Class B. The two different conditions are measured here. National Class 0 measures the spread of frame and the amount of heat released from the surface of a product. The Euro Class system measures, via SPI test, single burning item, frame spread, ignitability, amount of heat, smoke, and toxic gas release, whether the product melts, drips, or charts. This is more important because the Euro Class system focuses on the combustibility of materials, not just the spread of frames. It is possible that a product classified as Euro Class B also has the characteristic of a Class 0 product, but never the other way around. In 2009, the Locarno House fire, which claimed 6 lives. A 2013 inquest into the tragedy revealed that cladding installed on the building's exterior had accelerated the fire's spread. This work was commissioned by the Southwark Council, underscoring the critical role of oversight in construction and materials approval. Following the inquest, the coroner recommended a review of building regulations, specifically focusing on the use of combustible materials. Despite this recommendation, no significant regulatory action was taken at the time. Fast forward to 2017, the Grenfell Tower fire, which tragically killed 72 people, once again brought these issues to the forefront. The devastating loss of life forced authorities to confront long-standing deficiencies in fire safety regulations. In the aftermath of Grenfell, changes were finally implemented. In 2018, the Class 0 route, previously a standard for assessing fire performance, was finally removed as it was deemed inadequate. It was now replaced with stricter Class A2 requirements, which mandate non-combustible materials in building construction. These events serve as a stark reminders of the consequences of inaction and the critical need for proactive regulation. They underline the importance of ensuring that safety standards evolve alongside advancements in building materials and technique. The Grenfell Tower inquiry highlighted that the government was aware of ACP's combustibility as early as 2002. Despite this regulatory inaction and conflicting guidance allows such materials to remain in use with catastrophic consequences. One of the 4 products that did achieve Class 0 in BRE's test was a panel described it in its report as an aluminium sheet. When subject to a full-scale test, a system incorporating panels of that kind reached the failure criteria in Fire Note 9 at a very early stage, exceeding the external temperature limits within 3 minutes of the start and the internal limits after 4.34 minutes. Nonetheless, in its report dated 16 September 2002, BRE said only that the aluminium sheet product had satisfied Class 0, but had proved to be one of the worst performing products in the intermediate scale and single burning item test. It concluded by saying that as the current guidance in approved document B ask for Class 0 performance in diagram 40, those matters might require further consideration. There is no evidence of any discussions within the department about withdrawing diagram 40 and thus Class 0 as a relevant standard for the fire performance of the external surfaces of high-rise buildings. According to paragraph 7.89 of the report, one might reasonably question whether Mr. Bird or anyone else in the department, including Mr. Martin, studied the BRE report in any detail or really gave any thought to the implication of the result of the full-scale test using the ACM product. If they had done so, they would surely have realized that although it had a Class 0 surface, it was highly combustible and entirely unsuitable for use on the external walls of buildings, particularly high-rise buildings. Direct quote from paragraph 7.90, the Grenfell Tower Inquiry Report 2024. According to the building authority, specifically Mr. Bird, the use of ACM panels on buildings taller than 18 meters clearly violated functional requirements before subsection 1 of the building regulations. He believed that the general warning in paragraph 13.7 of approved document B, which cautioned against the use of combustible materials, along with the existence of functional requirements in B4 subsection 1, was sufficient to prevent the use of such products on high-rise buildings. This perspective assumed that industry professionals would interpret and apply the functional requirements with due diligence. However, the inquiry panel took a totally different stance. They found this position deeply unsatisfactory for two critical reasons. First, reliance on guidance. Following approved document B is widely treated as evidence of compliance with the building regulations. Yet, as the document is merely guidance, its prescriptive appearance often leads industry professionals to overlook the functional requirements it is meant to support. Second, lack of clarity in standards. The continued use of Class 0 as a fire safety standard creates confusion. If the authorities believed that some cladding panels with Class 0 surfaces did not comply with the regulations, they should have acted urgently, either by withdrawing Class 0 as a standard or by explicitly warning against the use of combustible composite products in approved document B. This disconnect between guidance and functional requirements underscores a systemic issue, the need for clearer, enforceable standards to ensure compliance and ultimately public safety. Here are the references used for today's presentation. Thank you for your attention.